Great. Some fascinating insights there from Rab in terms of the impact that 5G technology will have on the manufacturing sector. And if you'll notice, there's kind of a common theme that's been running throughout this whole conference today about 5G and the impact. So what we're going to do now is we're going to dive down a little bit deeper into 5G. So I'd like to introduce Dani Anderson. He's a 5G engineer at the University of Strathclyde software-defined radio team. So Dani, over to you.
Thank you very much, Mike. Thank you, everybody, for having me. I am Dani Anderson. I'm at the University of Strathclyde with the Strath SDR team. We have over 10 years of experience in spectrum sharing. We actually started our shared spectrum journey with something called TV Whitespace on the Isle of Bute. That was a project that we did in collaboration with BT, and that was to take advantage of some of the spectrum that was made available following the analog to digital TV switchover. And since then, we've branched out to a number of international collaborations and projects, and we're focusing mainly on software-defined radio to provide agile base station solutions for a number of different use cases and applications. Following on from the sort of initial TV Whitespace work on Bute, we did a live trial network on the University of Strathclyde campus in Glasgow. Then we moved on to a trial network in Orkney on the north of Scotland. And from there, again, we kind of branched into the start of our private 4G, now 5G networks with the 5G Rural First project. And that has allowed us, again, to continue to branch our projects into a number of different application areas, working with industry, working with governments, working with other academics, and working with communities, particularly those in rural areas, to address connectivity challenges. Some of those projects, 5G Rural First, I mentioned, that was a DCMS-funded project. It's a multi-partner consortium working in rural areas, led by Cisco Systems. BT were involved with that project to deploy multiple small cell solutions across the Orkney testbed. That project has matured and kind of continued as part of the 5G New Thinking project, which is still ongoing. And again, the emphasis there is on community-led, community-driven private 5G networks. 5G Rail Next, again, a DCMS-funded project, multi-partner consortium led by Cisco Systems. The focus there was, again, on private 5G networks, this time for delivering high-speed connectivity to trains and underground systems in both South Korea and Glasgow for delivery of augmented reality and mixed reality content. We also have the Wave 1 Rural 5G testbed in collaboration with the Scotland 5G Centre and funded by the Scottish Government. Again, software-defined radio, shared spectrum networks at a facility in Loch Lomond, the Ross Priory part of the university campus. We're demonstrating and developing a number of different applications, predominantly targeting rural connectivity. We also have the EPSRC-funded Affordable Rural Internet Access, or ARIA project. This is a multinational, international project, collaborations in Ghana, Kenya, Malawi, and Zambia, again, focusing on affordable rural communication using SDR and TV Whitespace. And then finally, we have our RF-SOC SDR programs, kind of in collaboration with Xilinx. This allows, this is working on really the kind of next generation of base station hardware and equipment. And this gives a high degree of sampling, and there's a lot of very interesting and very exciting projects happening with that hardware. But today I want to focus on kind of Industry 4.0, the fourth industrial revolution. We'll heard a lot about that today. We kind of know what the key aspects for all of that are. But really, we are looking at creating a more flexible, efficient, and sustainable production environment. And that's going to rely on a lot of different technologies. We're looking at machine-to-machine communications, things part of the Internet of Things, augmented reality, mixed reality, artificial intelligence. And the key thing that underpins all of those different technologies is connectivity. And we tend to consider 5G as a very strong candidate solution. There's a lot of those capabilities either already exist, things like ultra low latency, high bandwidth carriers, or they are being designed specifically with Industry 4.0 in mind. And I mean particularly things like the vertical LAN work item that's going to be part of 3GPP release 16. Again, some of the use cases we heard from Professor Scott earlier, but again, things like factory floor productivity, ecosystem monitoring, predictive maintenance, things that will kind of reduce costs and times of defects, increasing the monitoring capability. That's going to require a high volume of devices, and it is important that all of these things come with the high levels of security. Decentralized expertise, your areas of AR, MR, these kind of high bandwidth, low latency applications, again, with an emphasis on high security for sensitive information. Looking at elements of automated production, robots, artificial intelligence, video streaming. Again, this is low latency, high reliability, and typically very high bandwidth communication. And then aspects of your supply chain management. Again, very high security and will come with a very high device density. So a number of technology challenges that can be addressed there. And there's a lot of work going into the different 5G architectures and things that can be used to enable all of these different kind of applications. But within the Strath SDR team, we put a lot of emphasis on private 5G networks. And why is this? Well, that is because really it comes with we feel that the highest level of customization. You can really kind of tailor the deployment to hit the applications that are most important to the end users and the customers. This non-public aspect of it is particularly relevant for applications that have high security requirements or potentially need higher performance or quality of service than we can typically guarantee, maybe through a slice of an operator network. And when I say slice, typically we can allocate aspects of computing or networking resources for specific users, use cases, or applications. And we are at the point now where we can take our private 5G networks and implement something that we call neutral host. And neutral host networks can support then some of the operations and services provided by public networks, and we can support multiple different technologies and carriers simultaneously, which is something that we hope to demonstrate as part of our 5G New Thinking project. So one of the key elements that we see for encouraging private 4G and 5G networks, specifically for Industry 4.0, is the use of software-defined radio base station systems. And software-defined radio, or SDR, are radio systems where a lot of the signal processing algorithms that implement what we call the physical layer of the device, they're all adjustable and controllable through software. And these kind of software-enabled E-node Bs and later G-node Bs combined with software core networks are going to give a relatively affordable, flexible, scalable private network solution. Typically, these systems come with two main parts. We will have what we call a baseband unit, and this will be used to provide and process the operating stack, handle network operations, connect your radio access network back to your core network. And then we have the actual SDR element, which will be the remote radio head. And this is what is actually going to generate the carrier signals. It will contain the appropriate power amplifiers for your specific LTE or 5G new radio operating band. And this is what we call distributed architecture. It gives us a lot of deployment flexibility for radios. One of the large benefits that we hear talked about in 5G is this idea of standalone and non-standalone networks. And what do we mean by that? This is all to do really with the core network architectures that are used. And we can typically define 5G core networks as whether they use control signaling from the 4G evolved packet core, or whether the entire signals and control plane signals and user plane signals come from the 5G packet core. And at the minute, we see these non-standalone or NSA networks implemented as part of a migration strategy, moving from 4G to partly to full 5G service provision. It allows existing EPC assets to be used, take advantage of the 5G radio access technologies, the new radio standard, but doesn't give you the full benefits and advantages that come from using a 5G packet core. And these kind of things, while they're maybe not fully commercially available yet, these are the kind of things that you can implement as part of a private network solution. And in fact, we actually do these kind of solutions, and we have deployed these as part of the 5G Rail Next project. We had a complete end-to-end SA connectivity solution operating in what we call N77. We'll hear more about that later, but that typically refers to the frequencies between 3300 megahertz and 4200 megahertz, so a specific frequency portion. And you can see the different elements that would make up the end-to-end. So the user equipment, or UE, was a modem system connected to a commercial off-the-shelf compute platform. And then we moved to our G-Node B base station, which, as I mentioned, is a remote radio head component, the SDR component, and a baseband unit. And then we have next-gen signaling back to the 5G packet core. And you can see that every single element and every single aspect of that end-to-end solution is reporting 5G standalone. And this is all being done on a private core network with a private PLMN ID and custom SIM cards that were created by the Strap SDR team. But it's not all about your kind of broadband 5G NR carriers. There are aspects of it that involve enabling the Internet of Things. We hear a lot about machine-to-machine connectivity. So LTE-M, we can effectively almost consider a stripped-down version of the LTE standard for IoT applications. Significantly reduced bandwidth in comparison to some of the broadband connectivity. Does still support voice over LTE, does have mobility support. And as of release 14, some of these carriers can push up to kind of 5 megahertz in bandwidth, and we get better downlink and uplink data rates as according to that. There is then also our NBIOT, or narrowband IoT carriers. These are highly flexible, very small bandwidth, 200 kilohertz carriers. With that reduced bandwidth, you get the deployment flexibility. You also get a significantly reduced data rate. So we are looking at kind of only 200 kilobits per second for some of these applications. However, that benefit is that they're still within the capabilities that you need for kind of static sensor applications. These kind of applications that have maybe very reduced data consumption kind of applications. So this table kind of summarizes the different IoT options that are available in 5G networks. And with an SDR-enabled access network, we can actually support all of these different technologies and the kind of broadband 5G NR and LTE carriers, all using the same infrastructure. And this gives us designs that can be very flexible, can support multiple use cases and different applications simultaneously. It also makes these kind of networks a lot more affordable than it would maybe initially be considered. And it again tends towards enabling things like neutral host, which will kind of further impact the business model behind these private networks. The key thing underpinning all of this is spectrum. And we have kind of recently had what was a self-titled spectrum revolution in July of 2019 with kind of formalized shared spectrum. And that kind of came in two forms. We had the shared access license and a local access license. Shared access licenses kind of target 3 frequency bands that are available on a first come, first served basis, and I'll talk a bit about more of them in a little bit. And then we also had a local access license, and that allowed for application to a wider range of frequency bands. In fact, any commercially available frequency band. So that would be your kind of 800, 900 megahertz spectrums, and possibly also the spectrum that has just been made available with the recent 5G auction. There was an Ofcom consultation earlier this year about their kind of long-term strategy for the 2020s, as in the decade. So we could also see a potential expansion of this SAL and LAL model into wider spectrum bands. So spectrum really is becoming available for these kind of private networks, but spectrum access is only as useful as the ecosystem of hardware around it. So as we kind of continue to evolve the SDR base stations, we also need to see a similar growth in the user equipment options. And I don't just refer to commercial handsets from Apple, Samsung, Google, all of these kind of things. And we do also need to see a continuing support for antenna systems for some of these kind of bands. And then the different kind of applications that are going to be targeted by the private networks, they'll have different technical requirements, maybe in terms of what carrier sizes are available for the bandwidths, and what kind of propagation characteristics are available. Typically for rural deployments, in remote locations, we tend to favor the lower band spectrum for the better propagation. In an environment like a manufacturing institute, typically the propagation is less of an issue, and we would favor a higher capacity, higher frequency kind of link. But I think predominantly for Industry 4.0 applications, we are going to be targeting the shared access licenses. So that typically covers these 3 spectrum bands: this 3.8 to 4.2 megahertz, 2390 to 2400, and then a sliver of spectrum in 1800 megahertz. And all of these spectrum bands have different potential applications within an Industry 4.0 environment. However, again, as I mentioned, as the hardware ecosystem grows and develops, more bands become available, more spectrum options come onto the table for use in these kind of private networks. And a band of interest would possibly be in the 600 megahertz kind of frequency range, this LTE band 71, a low band spectrum with very good propagation characteristics, particularly for rural locations. So putting all that together, I'd just like to quickly talk about some of the engagement that the Strath SDR team have been carrying out in conjunction with the National Manufacturing Institute of Scotland, NMIS, at the AFRC, at the Advanced Forming Research Centre, part of the University of Strathclyde. So similar to the AMRC that we heard about earlier on, there is a tend towards testing and demonstrating sort of these key 5G features in a manufacturing-focused environment, to provide sort of quantitative performance evaluation. And the sort of key thing about this network design is that we want it to be replicatable by other institutes and research centres, so that they can continue to develop the understanding and the implementations of 5G networks that we know is going to be really important. So what have we actually done? Well, we have our kind of full network solution. We have our rack-mounted baseband unit connected over short internal fibers to our relatively high power remote radio head. We would probably call this a macro head solution. This is connected to an omnidirectional antenna, and that allows us to do a number of different access technologies, 5GNR, LTE, NBIOT, and LTEM, using the same remote radio head and antenna. Connect those to modem units, which will be integrated with the existing production floor equipment and computers. And that kind of reduces our dependency on commercial off-the-shelf handsets or other devices. So typically, we're kind of looking at a relatively small coverage area. We are only really looking to cover the production floor. So, this macro level coverage might actually be too much. So we have also gone to explore this small cell implementation. And this is using a different remote radio head. It's actually connected to the same rack-mounted baseband unit. It has its own independent antenna, but it is the same model of antenna. And this will serve LTE, NB-IoT, and LTEM connectivity to the same modems and modules that we are going to integrate with the production floor equipment. All of this will be done using a private PLMN and SIM cards that will be made by the Strath SDR and the NMIS teams. So this is really our kind of first attempt at a private network for industry. We are using a combination of the shared access licensing and then also some test and development licensing to run the network. We're looking at band 3, taking advantage of the shared access band where appropriate, branching into test and development licensing for some of the higher bandwidth applications. We are also interested in testing some of the lower bandwidth 700 megahertz spectrum options, and yet we are also branching into the much wider available 3.8 to 4.2 band, potentially looking up to 100 megahertz of operation for some of that. Some of the new SDR solutions that are available now, they will allow for multiple 100 megahertz carriers to be generated within that 3.8 to 4.2 band. Again, there are a number of different applications and things that we could look to support with this infrastructure. We've heard of some of these kind of previously, so I won't reiterate what has been said, but we are looking at things like digital factory, integration of OT and IT systems with the sharing of information, looking to provide a highly flexible design, very reconfigurable factory, reduce the amount of fixed cables that are in place, enable AI and reinforcement learning with high bandwidth carriers, AR and VR simulation and training environments. So really a wide range of use cases being supported there. Sort of looking slightly further than the Industry 4.0 kind of stuff, we do have other applications and other projects ongoing that show the benefits of private 5G networks. We have networks set up as part of our Green Economy Fund funded project, looking at smart energy systems, how to connect building management systems to get information on heat and smart meters, really sort of drive the green economy by and allowing the monitoring of energy usage within both residential properties and properties like large stately manors like Mount Stewart. And then we also have our collaboration as part of an IBC accelerator for 5G remote production. So again, another potential use case and application for SDR shared spectrum applications in a video production environment, kind of typically targeting sporting events. I'll allow for more cameras with potentially fewer operators to be deployed for these events, Yeah, thank you all very much for listening to me. I will be available for any questions regarding anything that we've spoken about today. Thank you very much.
Great, Dani, thank you very much. We've got 2 or 3 minutes left. You free? Okay, for a couple of questions?
Yeah, please.
Yeah, so one of the questions we've had come in, it has more to do with the backhaul. So do you see a big difference between, say, the 4G backhaul market and the 5G backhaul market?
There could potentially be a challenge with some of the higher bandwidth 5G applications. So within a 5G access technology, we can support carriers upwards of kind of 20 megahertz. So there might be a higher requirement put on your backhaul. It's always very challenging, and typically these things have to be considered on almost on a site-by-site basis. Again, a lot of facilities, if they are fiber enabled for backhaul, they will be more than suitable for 4G and 5G applications. For rural locations, a slightly different, more complicated conversation, and we maybe start looking at things like low Earth satellites and all these kind of different things for that. But.
Okay, great, thank you. And one other question, and it has mostly to do with, I guess, the timelines around some of these developments. I mean, I spend a lot of time talking to customers. 5G capability is really a hot topic with these customers, particularly the large corporates, and all of them are asking, when can I do low latency? When can I, do some of these other great things that 5G is promising? Having fast speeds is great. Big bandwidth's fantastic. When's this other stuff coming? Do you have any view on that?
I think some of those features, again, depending on exact requirements, some of these kind of low latency features, you could even have now. Maybe get in trouble for saying that, but again, a lot of it will be dependent on the under supporting architecture, what's available in your core network, and whether things like mobile edge compute through control and user plane separation, or CUPS, is available or supported. So some of it is available now, some of it we will see in the pipeline. It's never good to say imminently, but I'd like to say soon.
Okay, great. One final question. I think a lot of people who aren't really intimately familiar with the 5G marketplace or the technology behind 5G just assume let's just change out a few radio heads. It's no more complicated than that. I think you and I know, working in the space, there's a lot of engineering going on behind the scenes to enable the capability. So do you have a perspective on what you think the single biggest engineering challenge is, or the technical challenge is, to give 5G its full capability?
Oh, that's an excellent question. In terms of, I guess maybe on my own experience, I think, and we are sort of starting to see some of this being addressed. I think previously a lot of it has come down to access to spectrum, and we've seen not just in the UK, but we've kind of seen other regulatory bodies making more spectrum available for 5G applications. I'm thinking mostly, in Germany they have spectrum available for specifically targeting the next generation of manufacturing. So I think as we see more spectrum options become available, we'll see more deployment options become available. So that'll maybe help to address kind of multiple technology challenges at the same time.
Okay, great. Thank you very much. Well, on that note, Dani, thank you very much, and I'll bring this particular session to a close, and we'll see you a little bit later on in the panel discussion. Yep.
Yeah, thank you very much. I'll see you then.
Great. Thank you very much.